Hi, welcome to Python Polygon. So today our topic is going to be mensuration 2D and 3D. Okay, the topics I'm going to cover is area and perimeter, that is basically in 2D. Okay, then in 3D there is volume, there's CSA, there's LSA, and then there's TSA. Basically surface areas and volumes. Okay, so this is volumes, surface areas, and we can say perimeters. Okay, so perimeters comes only in 2D. So there are a few basic formulae that we need to know, like in a triangle. See, in 2D there is something called a triangle. It is three-sided. We know all that. Perimeter is A plus B plus C. Area is this given by Heron's formula, root S into S minus A into S minus B into S minus C. See, this is usually forgotten by some, so try to remember this formula. Then half into base into height we know. This and all we know. This also is fine. In rhombus, area is half into product of diagonals. Okay, this is important. This point. Okay, in trapezium, area is half into sum of parallel sides into height. Okay, circle we know. Okay, in 3D, cuboid is there. Cuboid, I think we know all the these things formulae. Cube, cylinder, it's okay. Hollow cylinder, cone, sphere. Okay, hemisphere. Okay, let's dive into the questions. So first question: Jack went to the garden for a picnic. He saw a board in the garden with area of the square garden mentioned as 625. Okay. He is curious to know what will be the area of a path of width 2.5 meter around it if the path is outside the garden. Okay, so if this is the garden, okay, this is the garden. So there is a path out around it and outside it. Okay, so this is the path. This is the path. Okay, so there is one dimension for this, that is the side length. Okay, if the area of a square is 625, that means a square is equal to 625. Okay, so area will be what? This is square root of 625 is nothing but 25. Okay, so now we know that the side of the park is 25 meter. Okay, and the width of the path is what? 2.5 meter. Okay, all right. So after this, what we can do, see, the whole path is there around it, right? It can be thought of as a bigger square, right? Because that is also nothing but a square. And then there's a garden inside, right? So this is the garden. And I want to know area of this whole path, right? So I can think of this as a big square. Okay. If this is a square, then what is this? This is nothing but the length of the path, right? That is 2.5, the width of the path. Okay, and that is 2.5. And then what is this? This is nothing but the side length, that is 25. Okay, and again one more length comes, that is 2.5. Okay, so this can be the side of the bigger square. Okay, so side of the bigger square will be area of the bigger square, that is including the path and the garden, is nothing but see 225 plus 2.5 plus 2.5 square. Okay, this comes as 90 square. Sorry, 30 square, which comes as 900. Okay, so if 900 is the area of this whole part, okay, and then we know the area of this inside garden as 625. Okay, so to get the outside path ka area, we have to just subtract area of the bigger square minus area of the smaller square, which is 900 minus 625. Yeah, 625, which comes as 275 in square meter. So that's the answer. Next question. Given that the area of a rectangle field is 6000, the ratio of the sides is 5 is to 4, what is the perimeter? Okay, so let's say the sides are L and B. L is to B is given as 5 is to 4. Okay, so from the ratios topic, if you haven't watched it, please go watch it. From the ratios topic, we can say that L is equal to 5 into something. Okay, 5 into x. B is equal to 4 into x. Okay, so here using this, I can get that 6000 is equal to area of the rectangle field, that is nothing but L into B, which is 5x into 4x, which is 20x square. Okay, this is area of the rectangular field, which is nothing but 6000. So x square comes as 300. So x is nothing but root 300. This can be written as 10 root 3. Okay. So if x is 10 root 3, what is L and B we need to find? Okay. L is what? 5 into 10 root 3, and B is what? 4 into 10 root 3. Okay. So this comes as 50 root 3. This comes as 40 root 3. Okay. Now they're asking for perimeter. Perimeter is nothing but 2 into L plus B. So perimeter is given as 90 root 3. Perimeter comes as 180 root 3. This is the answer. Fine. Next question. Given the diagonals of a rhombus are 26 and 14, find the length of its boundaries. Okay. So this is how a rhombus looks, and all sides are equal in a rhombus, and one diagonal is 26, one diagonal is 14. Okay. See, here we have to basically use one property of rhombus, that the diagonals bisect each other perpendicularly. Okay. So first of all, this is 90 degree, and this is equal to this. Okay. So basically, let's call the rhombus side length A. Okay. So we have this kind of here thing here, where this is bisected, and so is this bisected. Okay. So this becomes 14 by 2. That is 7. Okay. And then there's one A here. So I can clearly use Pythagoras theorem here. So I will get A is equal to root of 7 square plus 13 square. Okay, A is equal to root 49 plus 169. A is equal to root of 218. Okay, so if the side length, one side is A, all sides are obviously A because sides in a rhombus are equal. And one small property was that the diagonals bisect each other perpendicularly. Okay, like this. Okay, so perimeter is nothing but 4 into this thing, right? 4 into A. So 4 into A is nothing but 4 into root 218. So that's the answer. Next question. If the area enclosed by a circle or a square or an equilateral is the same, then the maximum perimeter is possessed by whom? Okay. So let's write area of a circle. Sorry, area of a circle is pi r square. Okay. So pi r square is equal to equilateral triangle is, see, this is one formula we need to know. It is root 3 by 4 into a square. Okay. And if you equate this to a square, the area of a square is nothing but side square. Correct. Now let's see, pi r square is equal to s square. Okay, so r square is equal to s square by pi. Okay, so r is equal to root of s square by pi. Okay, that is nothing but s by root pi. Okay, this is one equation. Second one is, we'll write s square and a square relation. S square is equal to a square root 3 by 4. Okay, so a square is equal to 4 s square by root 3. Correct. So a is equal to root of 4 s square by root of 3. Okay, that a comes as 2s by fourth root of 3. Okay, now these are the three things we need to know. Okay, now we have to find out the perimeter of each figure. Okay, perimeter of a circle is nothing but 2 pi r. Okay, if it is 2 pi r, I'll substitute this r formula, 2 pi into s by root pi. Okay, root pi and pi can cancel root pi times. Okay, you have the area of perimeter of a circle as 2 2 root pi into s. Okay, we'll keep that as it is. Next, perimeter of a square is nothing but 4 into s. Okay, we'll keep that also. Perimeter of square, and perimeter of the triangle will be 3 into side length, right? So 3 into 2s by fourth root of 3, which is nothing but uh, I can write it as 6s by fourth root of 3 itself. Okay. Now we need to analyze. Okay. See, this is 6 by see, root of 3 is 1.7. Okay. So this comes as 1 point, it's somewhere around 1.3. Okay. So when you divide 6 by 1.3, you will get 4.6. Okay. So 4.6 into s is what you have. Okay, perimeter of the triangle. 4.6 into s. So definitely perimeter of square is smaller than this, so we'll catch this. Okay, 4.6s is now the maximum. Let's check for this. 2 root pi into s is nothing but, see, root pi is what? Root of 3.14. Okay, 3.14 can be assumed as this only, 1.7, root of 1.7. So you get 2 into 1.7. This is 3.4. Okay, hence the perimeter of the triangle will be the maximum equilateral triangle. Next question. The area of the largest triangle that can be inscribed in a semicircle of radius r is, see, we need to know this one property. In a semicircle, the largest will be a right angle triangle. Okay, that is going to be this triangle where one side is diameter, that is 2 into r, and this is 90-degree, this point. Okay, so it's a right angle triangle at this point here, and this is an altitude drop. Okay, so basically the altitude drop will have length r, the base will have length 2r. Okay, we can see from this figure, if this is center O. Okay, so area of the largest triangle will be what? Half into 2r into r. Okay, which will get it as r square. Half into base into height. Simple. Next question. Circumference of a circle is 100 centimeter. Side of a square inscribed inside the circle is what? Okay, so if a square is inscribed inside a circle, then this angle is 90, because it is like, see, the whole 360-degree is divided into 4 parts equally, so all are 90. Okay, 360 by 4. Fine. Now see, we need to we have the circumference. Now we need to find the side of the square, right? Now this side length we'll call A. This side length also becomes A. Okay, this diagonal is nothing but the diameter, right? So the diagonal square is equal to A square plus A square. This we know. Okay, now the diagonal is what? We have to find out. Diagonal is nothing but diameter. Okay. Now we need to find out radius using this circumference formula. So we have 2 pi r is equal to 100. Okay. So we need 2r only. Let's substitute for 2r itself. So 2r, that is nothing but d, is equal to 100 divided by pi. Okay. So we have 100 divided by pi, the whole square, is equal to 2 into a square. Okay. This you can take it this side. So a square will be nothing but 1 by 2 into 100 by pi whole square. Okay, and now they're asking side length, so we'll take the root of this. So a is equal to 100 by pi, so because root and square cancels, into pi root 2, like this. Okay, so 100 by pi root 2. Yeah, we can cancel root 2 and 2 times, so 50 root 2 remains. So 50 root 2 by pi remains. This is the answer. Next question. A water tank is being used to supply drinking water in a city due to shortage of water. If the dimensions of the tank are 7 meter in length, 11 in breadth, and 3.5 in height, how many liters of water can be filled in the tank? Okay, this is nothing but a simple volume question. Okay, so volume is what they're asking. But there is one small trick here. Okay, see, first we'll find out volume in meter cube, that is L into B into H. Okay, this will be the volume. This comes as 269.5. Okay, 269.5 is the volume in meter cube. Okay, but they are asking in liters. How many liters of water? Okay, there is one small conversion factor here. 1 meter cube is equal to 1000 liters. Okay, this should be by hearted. Okay, this you should know. Okay, so to convert it into liters, we just have to multiply by 1000. Okay, which is nothing but 269 500. So this is 269k liters. Okay, fine. Next question. If Jimmy rolls a sheet of paper, not that sheet of paper, this is different rolling paper, initially square shaped along its length to make a cylinder. Okay, he rolled this paper to make a cylinder. Find out the ratio of the base radius of the cylinder to the side of the square. Okay, see, first of all we'll call this side of the square A. Okay, see, this whole A, okay, will become the circumference for the new cylinder. correct? Because it is rolled in that way. Okay. So then the circumference 2 pi r will become the side length a. Okay. They're asking base radius to the side of the square. Okay. So base radius something got r. R will come as a by 2 pi from here. Okay. So you need to find out the base radius to the side of the square. So this to side of square. That means you just divide this also by a. You will get the ratio that they're asking for as 1 by 2 pi. So 1 by 2 pi is the answer. Next question. A 5 centimeter cube which is cut into many smaller cubes of 1 centimeter as possible. Okay, fine. Is cut into as many. Okay, fine. What will be the ratio of the surface area of the original cube to that of the sum of all the smaller cubes? Okay. So first of all, we need to find out how many cubes it is cut into. Okay. Whenever these kind of questions come, where a volume is cut into different volumes, okay, we always equate the amount of volume. Okay. So volume of the smaller cube, volume of the bigger cube, okay, volume of the bigger cube is equal to n into this. N is nothing but no a number of cubes it can be cut into. Okay, number of 1 centimeter cubes into volume of the smaller cube. Okay, so you get the n from here as volume of bigger cube by volume of smaller cube. Volume of a cube is a cube. So if it is 5 centimeter, it will be 5 cube. If it is 1 centimeter cube, it will be 1 cube. So this is nothing but 5 cube. 5 cube is 125. Okay, so 125 pieces will be cut. Okay. Now let's see. Ratio of the original cube is what? Surface area of the original cube. Surface area of a cube is nothing but 6 into a square. So let's find out the first surface area. Okay. Original surface area is nothing but 6 into 5 square. Okay. That is 25. 25 into 6 is uh, 2s are 50, so 3s are 150. So this is 150. Okay, 150 centimeters square. Okay, now n into they told the sum of all the surface areas. Okay, so it becomes n into surface area of the smaller cubes is nothing but n is 125 into 6 into 1 square. Okay, because 6a square. So this comes as 0 carry 3, 12 are 5 carry 1 and 750. Okay, this is centimeter square. Now we have to take the ratio. That becomes 150 by 750. This and this cancels. This becomes 3 times. This goes 15 times. This again goes 1 by 5 times. So 1 is to 5 is the ratio. Okay. The original surface area will be very small. Some of the new surface areas will be very big. Next question. A drum is full of water. Diameter of the drum is 35 centimeter. The level of water will be dropped by how much if 11 liters is taken out? Okay. So diameter is given to you 35 centimeter. Okay. Then see, we can find out first the volume in see they told liters, but we want it in centimeter cube. Okay. So we know one conversion rate. 1 meter cube is 1000 liters. Okay. Yeah, so we know 1 meter is equal to 100 centimeter. So 100 centimeter cube is equal to 1000 liter. Okay. So here we can write this as 100 cube. 100 cube we know is 10 to the power 2, 2 to the power 3. That is 10 to the power 6 centimeter cube is equal to 10 to the power 3 liter from here. Okay. So we can cancel this 10 to the power 3 times and 1 time. Okay. So 1000 centimeter cube is equivalent to 1 liter. Okay. So now if it is 11 liters, this will be 11,000 centimeter cube. Okay. So 11,000 centimeter cube is equal to pi r square h. Okay. This is the height and this is the radius. Okay. Radius is nothing but it is given as 35 by 2 because 35 is diameter. So 11,000 is equal to pi will substitute as 22 by 7 into 35 by 2 the whole square into h. Okay, so here from this equation we need to find h. So h is equal to 7 into 11,000 into 4 because this 2 square divided by 22 into 35 into 35. Okay, so this can cancel 5 times here. 22 can cancel 2 times with 11,000 1,000 times. Okay, and this goes 500 times. So we are left with 100 into 4 by 35. Okay, so again we can cancel this 7 times and this 20 times. So we get height as 80 by 7 centimeter. That's the answer. So the height decreased by 80 by 7 centimeter. Next question. A metallic hemisphere is melted and recast in the shape of a cone with the same base radius. Then we have to find the height. Okay. So basically the volume will remain same, correct? So volume of hemisphere is equal to volume of cone. Simple. Okay, volume of hemisphere is half into volume of a full sphere. That is 4 by 3 into pi into r cube. Okay, this is equal to volume of cone is what? 1/3 pi r square h. Okay, h we need to find. R is same they told, so I'll cancel these two r's and these two r's. Okay, pi and pi can cancel. 1 by 3 can cancel. So I get this cancels two times. So 2r is equal to h. That's all. Next question. A hollow sphere of internal and external diameters of 4 and 8 are melted into a cone of base diameter 8 centimeter. The height of the cone is what? Okay. Hollow sphere means this, okay? Like there is some boundary to the sphere, okay? There is a boundary to the whole sphere, okay? But there's nothing inside, okay? It is empty inside, okay? Some people tell no, they feel empty inside. So empty inside. Okay, so how do we find out the volume of how much material is used here? We need to understand. Okay, so can we write the material used as volume of the larger sphere minus volume of smaller sphere? Correct, no? So the internal diameter is 4. That means internal radius will be half, and similarly for the external diameter. And then we'll have volume of the material will be nothing but volume of larger minus volume of smaller, which is 4 by 3 pi into r of larger cube minus r of smaller cube. Can I write it like this? Because I took common. Okay. So larger radius is what? 4 centimeter. So I'll write it as 4 by 3 pi into 4 cube minus smaller radius is 2. So that is 2 cube. Okay, so to simplify further, I can, yeah, now this volume of the material, okay, volume of material is recast into a cone with base diameter 8 centimeter. Okay, so base radius is 4 centimeter. Volume of cone we know 1/3 pi r square h. Okay, so radius here is not the same, it is 4. So 1 by 3 pi into 4 square into h is equal to 4 by 3 pi into, I can take 2 cube common because it's there in both the sides. 2 cube minus 1 is the this thing. And 1 by 3 pi and pi can cancel. 4 can cancel with this 4 one time. So 4 into h is equal to 2 cube is 8. 8 into 7. Okay. So h will be nothing but 14. So that is the answer. Next question. A cylindrical container of radius 4 centimeter contains some fluid. Okay. A solid sphere of radius 3 centimeter is lowered into the fluid until it is completely immersed. Okay. Find out by how much level will the fluid rise. This is basically an application of Bernoulli's principle, where Bernoulli's principle says that suppose you had some liquid, now you put some body in it, the level will rise such that like the whole volume will accommodate the volume plus of liquid plus volume of the body immersed in it. Okay, so we will find out that only. Now see, the cylindrical container has radius 4 and a sphere of radius 3 is added. Okay, so basically now let's the volume displaced. Okay, the volume displaced we know is volume of the object added. Okay, we can agree on this, right? Now volume displaced is what? How do I calculate that? Pi into r square into height displaced. Okay, so that is nothing but how much the level the fluid will rise. Okay, it is equal to volume of the object. Volume of the object is 4 by 3 into pi r cube because it's a sphere. Okay, and this is nothing but radius is 4 centimeter here, not the same. Okay, so pi and pi can cancel because that is the same always. R square here on this side is the radius of the cylinder, that is 4 square into height it displaced is equal to 4 by 3 into 3 cube. Okay, so this can become 3 square, this can become 3, and 4 and 4 square can cancel, so height becomes 9 by 4. That will be the answer. Last question. Radii of two cones of copper and aluminium are in the ratio 3:7. Considering their volumes to be equal, find the ratio of their heights. Okay. So the radii of the cone are in the ratio 3:7. Okay. Their volumes are equal. So I can write pi r square h r1 h1 equal to pi r2 square into h2. Okay, the radii are in the ratio 3:7. Okay, so r1 is to r2 is 3:7. So using the ratios concept again, r1 can be written as 3x, r2 can be written as 7x. Okay, so now pi and pi can cancel clearly. Okay, so r1 and r2 I'll get this side, r1 by r2 the whole square is equal to h2 by h1. Okay, r1 by r2 is how much? 3:7, right? So 3 by 7 the whole square is equal to h2 by h1. Okay. 3 by 7 is nothing, the whole square is nothing but 9 by 49 is equal to h2 by h1. Okay. This is the ratio of the heights, but they didn't ask h2 to h1. They asked the same h1 to h2. Okay. So I will just invert it. h1 by h2 is nothing but 49 by 9. This will be the answer. 49 is to 9. So with this question, we come to the end of this topic. I hope you liked the video, and I'll see you guys in the next topic. Thank you.